Hi there, welcome back. What we have here is a device that I've been looking forward to for some time. I received it, built it, and this is the subject of this video today. What this is an FM stereo signal generator. And this is a device that I would have found very, very useful when I did the Pioneer SX1050 project, because in that one you needed to do alignment of the FM with a proper stereo signal generator, one that would give you the pilot signal, variable levels, output levels, and so on and so forth. And the only thing I had was this magical device, which you've probably seen. I've used this quite often. It's a little FM transmitter that you plug onto your phone, and you can hear the music coming out of your phone on the radio. This thing is fine to give you a frequency that you can check the RF alignment for, but it certainly is not accurate. It's certainly not clean. In other words, there are spurious signals coming out at different frequencies, and that's just not good enough. Now, what I did want was, I wanted something like an HP8657 signal generator, the one that quite a few YouTubers that I follow use, people like X-Ray Tony and so on. That is a fantastic device, but it is rather big. It is rather expensive. It's very, very accurate. And I'm not putting aside the possibility that I might get one day, but I just can't justify the expense right now to use it for the number of projects that I need it for. So I reached out to ELV when I found this device, which I thought was actually quite amazing. It's a stereo signal generator that provides everything that you need to test a stereo receiver. And by default, obviously, it can also be used to align and test my vintage receivers, the normal FM stuff that I work with, the tube radios. And I contacted them to get some more information. Everything is in German, unfortunately, for me. They actually decided to offer me this device if I would show the build on my channel. And I would have done that anyway, but I want to thank them for that. I also decided to go ahead and translate the manual they provide into English, and that's become quite useful during the build of this project. I found that ELV is actually a world on its own. It's a candy store for people like me. It's got so much stuff on offer. It's in Germany. The delivery is fast and safe. So I think I've found another place to spend my money at. That was a good decision on their part. Anyway, the build of this device is what I'm going to show you here. They have a very, very good video on the build itself on their site, and I will link it below. It's probably better filmed than mine because it's more close-up and in a lot of detail. There's no English. There are a few German titles on there, but it's pretty self-explanatory, actually. This worked out to be quite simple to build. And I'm sure this thing's going to come into a lot of use. It's going to get a lot of use in the alignment and restoration of my radios. So if this seems at all interesting to you, stick around and make up your mind yourself. Let's get cracking. I'll start exactly the same way they do, which is to lay out the components so that you A, can find out whether you've got everything, and B, you can very clearly see what everything is meant for. Now looking at this, we can start separating the different groups. The chassis or the cabinet takes the knobs. Let's put them together, get them out of the way. It also uses the, this is the knob for the rotary encoder. The OLED display goes on this board and it has this support, so we'll put that aside. All this stuff here is to really build up the battery connector or the battery pack. So we'll put those aside. This is the light pipe for the LED. We'll put that with the chassis. And what we're left with, really, is this. 3 components to go on the board. And it's pretty obvious where they go. We'll start with the RF connector. Then the rotary encoder. and the LED with the longer pin going to the positive, which is indicated on the board. And we're ready for soldering. The LED is soldered flush to the board because you have a light pipe to direct the light onto the front panel later. And our board is done. Next we've got the display holder and board to mount. Now the first thing to do is to take off this side of the double-sided tape. There we go. Now this fits on the back of this guy. There are 3 little holes here. It can't go anywhere else. So it's pretty self-explanatory. It guides its way in. Press it tight. There we go. Now we've got to remove this side of that tape as well. And we're ready for the next step. Now what you do is you take your display, you've got that little socket there, you plug this right in there, and then you've got to push that clip down to catch it. There we go, there's just a little black clip, that's like a holder. Now you fold this thing back, and it's going to stick into that tape. Now make sure that it fits properly, and just gently tighten it, and we've got our display done. Now all we need to do is connect the display onto the board. There are 3 just protectors on here, which take those out, and they fit quite obviously like that. Can't go wrong. Well, you can, but you shouldn't go wrong. Make sure they're in place, and then gently push them in. There we go. It's done. Perfect. And we've got to fit these connectors in here. Now don't get them wrong. The negatives are the one with the spring. These are the positives. You can see positive in there and positive in there. There's the positive, there's the negative. Now we've got to fit these guys in their respective cavities. It's pretty simple. Everything is snug. And these guys come through on the side. Now we're going to connect those 2 together. It helps to tin this just gently. Take a little black wire and you connect the 2 together. Now we just straighten this out, put this through those wire guides so they fit flush. Perfect. Nice and flush. Now we need to solder the black wire over here. Black goes here. Red over here. Now the idea is to guide these guys. This one comes through here. And this one comes through here. Give it a bit of leeway so there's no stress on the wire. And then you bend them down through the guide, the back, and out the front. And there you have it. Now what you'll be doing is connecting this battery holder to here. So you need to trim those wires and tin them where those two connectors are on the underside. You see those two there? That one and that one. So we just prepare those wires to solder on there. Something like that. Ready to solder. Now we've got to turn this board around. And we use those two screws. Remember the two screws? To go in there. And in there. And we tighten that up. It's completely sturdy. Now we just need to solder those two. And we're done. And we are done. We're nearly there. Put in the little light pipe into there. This is going to go over your LED. Now we connect the push buttons to their respective switches here. Okay, we'll straighten that out when it goes into the front plate. And now we've got the rotary encoder knob, which just clicks in there. There we go. That then goes on top of this guy. And it looks like we're about done. Remove the protective cover. Put in a couple of AA batteries, but be careful with the polarity, obviously. If we click this now, we've got it starting up. Brilliant. Hold it down, it switches off. Time to put into the casing. Sliding it in, I only had one change to make, one little alteration. I had to really clip the wires coming out of there. They have to be flush, so I just clipped those a little bit and it fits perfectly. Now all I need to do is slide the lid on here, slide in. Make sure those are well aligned. And we're there. Perfect. The feet are already on. On the original video they show you how to put the feet on. These feet are on. And this thing is done. Switch it on. Now the operation is all done via this rotary encoder, which has a push button as well. You click that in and you get all the options, and each one has more options, obviously. So if we go into, for example, RF power, we can adjust the power in dB microvolts. Exit. We've got presets which we can program: 91 megahertz, 100 megahertz, 108, RF power on, RF power off. Now everything you do on the menu, or the tree of menus, is reflected on the screen, which is great. You literally know exactly what you're doing at all times because it's always on the screen. But I'm not going to go through the menus right now on this clip because I'm going to load the software. Now the software is provided by them. You just go to the product page and under downloads, You download it as a zip file and simply install it. I've got mine on my Windows PC running Windows 10. It installs with no problem at all. And then when you connect this via the USB connector to the PC, it detects it automatically. It also detects this as a sound card so that it can actually send audio to modulate the FM. So you can modulate your carrier with audio coming out of your computer. It can be music, it can be a test signal, it can be a speech file, whatever you want, it modulates it via the computer. So let me run the software and I'll show you what happens on here as we adjust things on the actual software, because it's a lot simpler to see what you're doing with the software than it is to do it via the rotary encoder. This is the software running now. It's very simple, and what I need to do to make it operate is to connect it via USB to my device over here. Watch the screen on the bottom right where it says RF off. There's RF on. It is absolutely instantaneous control. Off, on. So everything I do on the software is immediately reflected to the device. If I want the audio modulation to change, I can change it here. I've got mono at the moment, I can make it stereo. My limiter can be activated or deactivated, and that will prevent distortion. And I can also then mute various parts of the signal, left plus right, right, or just simply off, no muting. The source is now interesting because I can use an audio analog source by plugging in to there, to the 3.5 millimeter stereo jack. So I can choose analog to get that audio coming through. When I say coming through, that's the audio that will modulate the FM carrier. Digital means it's coming from my computer, where my computer sees this device as a sound card. Then I've got 3 test tones, 100 Hz, 1 kHz, and 10 kHz. Those are all reflected on the screen, as you can see on the top right. If I go to this end, I've got the RF level. At the moment, it's at 97 dB microvolt. I can increase that, and it goes as high as 118. And the low end is 88. I can also just type it in and enter. 88 dB microvolts, so from 88 dB microvolts to 118 dB microvolts. Now that is actually fairly high. This is the first question I have about this device. And it's recommended that you connect this directly to your aerial, your FM aerial antenna input. Even 88 dB microvolts is pretty high as a voltage. Or maybe I misunderstood this, because my understanding is you probably need a pretty good attenuator to get the sort of the microvolt levels that you would need to test a proper sensitive receiver with. But anyway, we'll get to that as we start using it. Now, the other thing we can change is the frequencies. Maximum is 108. As you can see, I can reduce that in tenths of megahertz anywhere I like. I can also simply type in, there we go. The screensaver timeout is a bit too low. I've got to increase that. But I can increase that, decrease that, and it goes as low as 87.5, which is the case, which is what happens with practically all FM receivers. Now at the top end, most of the modern, well, all the modern receivers will go to 108, but some of the old receivers will only go as far as 100, which is fine. You can set that frequency. Let's go back to 88. If I click set frequency now, that'll set it to S3. If I click S2, that is at 100. I can make that 101, for example. And I can save it, so it's readjusted the preset frequency, and of course station 1 I've left at 91. What else do we have here? Okay, we've got the audio levels or deviation. Again, all these are available on the rotary encoder, but you can adjust the deviation. The factory defaults are at 68.25 kilohertz for audio. There's the pilot signal and there's the RDS signal. Now obviously this pilot signal will only be transmitted if I've got stereo selected. The RDS signal will only be transmitted if I've got RDS on. I leave it as defaults. The total then is 77 kilohertz because it's the sum of the three bandwidths. We've got the pre-emphasis, which is what normally happens to a signal at a radio station. In Europe, it's at 50 microseconds. In the USA, it's 75, and you can also send a signal with that off. I'll leave that at 50. You can adjust what messages you want the RDS to send and the TA on and TP on. You can do all that, which I'm probably not going to need, at least not for the vintage receivers. Now, the one concern I have, as I said, is the power. I think this might be too high. So what I'm going to be doing next is I'll be using this to align my receivers. It's very simple for me. If I can't get if it's too strong a signal to go straight into the antenna, I'll just put a piece of wire and basically transmit it from the vicinity. I can do all the other controls, that's no problem. I can also try the switchable pi attenuator. I'm not sure how that's going to behave at 100 megahertz, but it might be interesting to see. But for now, that's about all I'm going to experiment with, and if you want to see this thing in operation, you will be seeing it occasionally on the restorations of my radios when I do the alignments, the FM alignments obviously. Well, that's it for my build video. I want to thank ELV for sending me this device. As I said in the beginning, I wanted to buy it. I contacted them. They offered it to me. I'm pleased to say that this thing has proven to be quite an easy build, very easy in fact. Most of the kit is actually built for you, which is great because SMD components are not that much fun to solder, especially if you don't have all the equipment. But I was very happy to discover the world of ELV. It's really amazing. The amount of kits and products they sell baffled me. It's like a kid in a candy store. I've looked through the magazines, which obviously is a bit difficult for me because I don't speak German, but you know, schematics are schematics, and usually the electronics is pretty understandable. But I want to thank them, and I want to thank you for sticking around. If you've enjoyed this, click like, share, subscribe, and all that jazz, and I'll see you again soon for another video. Thanks for watching. Bye for now, and stay safe.